Here we have an example of several exponential functions of the form y equals a times b to the x. So let's remind ourselves, what does it look like when you have an x that's exponential, because x is up in the power zone. It's an exponential function. What does the graph generally look like when you have an exponential function? Well, it goes through the point up here at A. This hits up at A, and it rockets up. The bigger, when B is larger, graph rises faster. So the bigger B is, the faster the graph rises. And A is the point where it hits on the y-axis. Why is that? I don't want to give you rules without reasons. If you plug in 0 for x, y equals a times b to x. If you plug in 0 for x, you're going to get y equals a times b to the 0. What's anything to the 0 power? Do you know that? It's 1. So a times 1, this is just a. So over 0 up a. That's why the point over 0 up a is on the graph, because if you plug in x 0, you're going to get it. So that's why that's at A. And then as far as the B, like if you plug in 1 or 2 for x, that's going to make B like to the second power, which means A times B, doesn't it? So the further you go to the right, 1, 2, 3, if you do third power, that's going to be A times B to the third, which is A times B. So you're going to multiply by B more and more and more again. So if B is larger, that's going to make your graph go up faster. All right, we're ready for their questions with that insight. Which graph has the largest value for B? So which graph, remember what B is, the larger B is, the faster your graph rises, because you're going to multiply by B repeatedly. Which graph is going up the fastest? Certainly A, right? Largest B. So that's that's the red graph. So I'll just say the red graph. Next, which graph has the smallest b? So which one is going down? Now for these ones going down, yeah, I didn't mention that. For what makes a graph go like this? This is when it goes down when b is less than 1. It goes up when b is greater than 1, because you're multiplying by b again and again and again. So if you multiply by a number bigger than 1, if b is greater than 1, multiplying by a number bigger than 1 makes things bigger, so the graph will go up. If you multiply by numbers smaller than 1, those are fractions, right? What numbers are smaller than 1, like 0.5? That's half, isn't it? If you multiply by a half, you take half and half and half, you're getting it smaller and smaller and smaller, like cutting a candy bar in half, and then half of that, and half of that, and it gets really, really tiny after a while. If you're multiplying by b again and again and again, which is what this exponential function says to do, right? As you go to the right, 1, 2, 3, you're plugging in 1, 2, 3 for x, which means a bunch of b's are going to multiply, and if those b's are all fractions less than 1, the thing's going to get smaller and smaller. So these guys both have b's less than 1. These guys all have b's greater than 1 because they're going up. So which one's going down the fastest? The black graph, the K. Smallest value must be that black graph. It's going down the fastest. Finally, which graph has the largest value for A? Now what's A? A is where it hits on the y-axis, isn't it? And so largest A, which one hits the highest up? That's right here. That's the largest A. That's the blue graph. So this one would be the blue graph. So there we go. Just getting used to the characteristics of exponential functions.